Hello class 9th, welcome back to online classes. Children, hope you all are good. And today in this video we'll start a new chapter, that is your gas laws. Let's start the chapter gas law. Now your chapter is study of gas laws. Actually gas laws are the laws by which we can explain the behavior of gases under the given conditions of temperature and pressure, because gases they behave different in on increasing temperature or decreasing temperature or on changing pressure. Okay, let's start the chapter. First, all of you know that gases they have certain properties which differentiate them from solids and liquids, and they are as you know that there are three states of matter, that is a solid, liquid and gases. The gases they differ from solids and liquids in the following ways. Gases they do not have definite shape or volume. Why? Because all of you know, because the particles in the gases they are far away from each other, and they can take the shape of any container in which they are kept. But in case of solid and liquid, what's happened? They have a definite shape and definite volume. Liquids have no definite shape, but solids have what? Definite shape and definite volume, and liquids have definite volume, right? Next is here, the distance between the molecule is much larger in case of gases. All of you know that the distance between the molecule is much larger in cases of gases, because all of you know that in gases the molecules are far apart from each other, so there are large spaces are there, right? But in case of solid and liquid, in liquid the spaces are less than gases, and in solid these spaces are minimum, means they are very close to each other, so we can say the distance between the solids, it is negligible. Because next is here, the force of attraction between the molecule is negligible in case of gases. Why? Because they are far away from each other, because the intermolecular space is large, so force of attraction is negligible, right? But in case of liquid and liquid and solids, in liquid it is more than gases, and in solid the intermolecular force of attraction is maximum. The molecules of a gas move in a straight line under random collision. Actually it is because there are a lot of spaces there, so they can easily move from one direction to other direction, means just they can move randomly in any direction. Wherever they get space they start moving, and then what's happened? They strike with the other molecule, or they strike with the wall of the container, right? So what is saying? Molecules of gas they move in straight line, undergoes random collision with the other molecules, and occupy the complete space available in the container, unlike solids and liquids. Right? Now these behavior or characteristics properties of gases, they are explained on the basis of kinetic theory.
One of the properties of gases is that gases have neither definite shapes nor definite volumes. It is mentioned in the kinetic molecular theory that the molecules of a gas are always in a state of constant, rapid, random motion. Also, there are negligible attractive forces between the molecules of a gas. Therefore, the molecules can readily move from one place to another, and hence gases can occupy the whole space available to them, due to which they have neither definite shapes nor definite volumes. Then the next property of gases is that gases have low densities. According to kinetic molecular theory, there are large vacant spaces between the molecules of a gas. It means in a gas, the molecules are far apart from each other. Therefore, the number of molecules per unit volume of a gas is very small, and hence the mass per unit volume of gas is very small as compared to solids and liquids. And due to this reason, gases have low densities. The next property is that gases are highly compressible. According to kinetic molecular theory, there are large vacant spaces between the molecules of a gas. So, when pressure is applied to a gas, the molecules come close to each other, and therefore the vacant spaces between the molecules are very much decreased, and hence the gases are highly compressible. The next property is that gases are highly expandable, means the gases can expand to a large extent. When the pressure on the gas is decreased or temperature is increased, the molecules of a gas move away from each other and vacant spaces between the molecules are increased to a large extent. Hence, the volume of the gas increases, or we can say that the gas expands. The next property is that gases exert same pressure in all directions. Kinetic molecular theory states that the molecules of a gas are always in a state of rapid random motion, and during this motion they collide frequently with one another and against the walls of the container. Whenever a gas molecule strikes the wall of a container, it exerts some force per unit area, which is called pressure. And it has been found that the number of gas molecules striking the walls of the container per unit area per unit time is same. And if the number of molecules striking the walls of the container per unit area per unit time is same, it means same amount of force is exerted per unit area per unit time. Therefore, gases exert same pressure in all the directions. The next property is that gases show diffusion. According to kinetic molecular theory, the molecules of a gas are always in random motion and there are large vacant spaces between the molecules of a gas. So, when two gases are brought in contact, the molecules during their motion move into the vacant spaces of one another. Therefore, gases show the property of diffusion. For example, when the bottle of perfume is opened in one corner of the room, it spreads throughout the entire space in the room in no time as perfume molecules diffuse into the air molecules. We know that the properties of gases are very much different from the solids and liquids. So let us see how do gases differ from solids and liquids. Firstly, the vacant spaces or the voids between the molecules of a gas are much more as compared to in solids as well as in liquids. Secondly, the gases do not have definite volumes, whereas solids and liquids have definite volumes. The attractive forces between the molecules of a gas are negligible as compared to in solids and liquids. As the molecules are very far away from each other in gases, therefore, the gases have very low densities as compared to solids and liquids. As the molecules of gases are always in random motion, therefore, the gases diffuse at a fast rate, whereas liquids diffuse slowly and solids do not diffuse. The gases do not have any free surface, whereas liquids have one free surface and solids have any number of free surfaces. Gases expand or contract up to a large extent on heating or cooling respectively as compared to solids or liquids.